We are group 16. Today we are going to talk about the biomechanics of push-up.
There are actually two main uses of push-ups. First is for fitness assessment, and second is for fitness training for upper body strength, power, and muscular endurance, which is also called strength conditioning. Actually, push-up has been long advocated as the means to assess local muscular endurance for the upper body. Research actually shows that there is a high correlation between push-up ability and a number of bench press repetition performed as a percentage of body weight, thus providing an efficient and inexpensive alternative to free weight testing. In a fitness setting, push-ups are widely used to develop upper body strength, power, and muscular endurance. They are staple exercise in fitness and gym classes. They are used by strength and conditioning professionals to train athletes in sports. They also played a prominent role in basic training programs of the U.S. military. There are actually different muscle groups involved in push-up. The two major muscle groups are the chest muscle group, which is the pectoralis major and the pectoralis minor, and the tricep brachii. The other muscle groups involved are the shoulder muscle groups, which includes the deltoid major and the deltoid minor. The upper and middle back muscles, which is the latissimus dorsi, rhomboids, and trapezius muscles, and the biceps, and the serratus anterior. Also, our lower back muscles, our abdominal muscles, and our buttock muscles, which is the gluteus maximus and medius, and our legs muscles. According to the Canada College Fitness Center, one standard push-up muscle is actually first flexing at elbows, lowering the body and maintain neutral spine. Then, your elbow must be flexed to 90 degrees at the bottom of the movement. And lastly, push back to the standard position. So, what are the benefits of doing push-up? Obviously, it's a powerful full body workout and develops pushing strength and power for upper body. According to the ACSM, push-up is considered as one of the exercise of strength training. So actually, according to the ACSM, we are advised to do 2 to 3 times of strength training exercise per week. And the benefits of strength training includes for younger people, it increases the bone formation, and for more older adults or just adults in general, it maintains good body strength to avoid osteoporosis and lowering the fracture risk. It can also control blood glucose level, reducing the risk of diabetes. So today we will be demonstrating a standard push-up and a knee push-up. Let's watch the video.
No. No, 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 no.
A few moments later. After the video, let's dig into the biomechanic breakdown of push-up. In fact, push-up is a cold kinetic exercise where the distal aspect of the extremity is fixed to an object that is stationary. Therefore, the angle and the leverage ratio of body muscle and joints plays a critical role in the motion stabilization. In terms of joint arthrokinematic, the gyrohumeral joint, radiohumeral joint, and elbohumeral joint would interact with each other and cause a series of push-up movements. In terms of muscle contraction during the concentric phase, the pectoralis major is working horizontally to adduct the shoulder. The anterior deltoid is used to flex the shoulder and stabilize it, and the tricep is working to extend the elbow joint. During the eccentric phase, the pectoralis major is controlling the shoulder into the horizontal abduction. The anterior deltoid is controlling the shoulder into the extension and stabilize it, and the tricep is controlling the elbow into the flexion. On these pictures, our coach Jennifer has demonstrated the detailed technique of push-up and knee push-up. Beside here is the free body diagram that Jennifer will be explaining it in the next session.
So here we're doing a biomechanic analysis of the full push-up and knee push-up. First, we can see the pose of the full push-up. The starting position is that your holding a high plank position as shown in the diagram here, and the ending position should be shown in the first diagram, in which your body is actually a straight line parallel to the ground with your chest nearly touching the ground. For our analysis, we take our feet as the pivot points and we take moments here. As we are doing push-ups at a constant angular velocity, the anti-clockwise torque must equal to the clockwise torque. And anti-clockwise torque is given by the force exerted by your hands, which is here. And the clockwise torque is actually given by the body weight, which can be calculated as 9.81, the constant of gravity. And after a round of calculation, we can see that force exerted by our arms to lift the body is 359.5 N. And actually, this is just a reaction from a downward pushing force. Remember Newton's third law? Let's move on to the analysis of the work done to lift your center of gravity per push-up. So the work done is given by the equation mgh, which is your mass times the gravity constant and the height of the center of mass traveled per push-up. And it's calculated here, and it gives the work done of 204.7 joule. And there are two assumptions. The first one is that we assume the body is a rigid body so that we can take moments properly. And this again stresses the importance of keeping your core tight and your spine in neutral position. The second assumption is that no external force is acting on the body. That means no stray movements, no turning, and again, this is another importance of having a strong core to hold yourself tight throughout the whole movement. And in our mistakes, I mean in the wrong postures given by the two subjects, one of them are actually doing half push-ups. So again, if we are doing the analysis of the torque, we're still taking moments at our feet, and the force required per push-up is still constant, given that we are doing in a constant angular velocity, but the work done will be significantly less as the distance of your center of gravity is actually less. So for the same force and for the best training effects, we strongly recommend you to use the full form, the correct form of push-up. And move on to the analysis of knee push-up. We do it for the same way, and except for one point is that the pivot point is no longer your feet, but your knees is here. And part of your weight, part of your body weight is actually supported by your knees. And again, we take moments at the pivot point, and according to a research article, the force exerted by your arms on pushing yourself up is approximately 50% of your body weight, and it's calculated here, 279.5 newtons. And the body weight here is actually less than expected, less than my mass times 9.81, and the work done per push-up is not given by mgh anymore. It's given by the distance of this new piece, new center of mass, times the new weight, with the weight eliminated by your knees, and it's given by another equation here, and the result is 175.1 joule per push-up, which is not really much less than a full push-up, but the best thing is that the force required is significantly less. It's 279 versus 359 newtons, and this is actually beneficial for female or beginners who has a lower upper limb strength to get started with this kind of exercise and to build up the muscular strength.
Thank you for the sharing of our coach Jennifer. I believe that from now on, our audience would get a better understanding of the biomechanics of push up. So this is the end of our presentation. Thank you. And here is our reference list.